What is up, Math 20-1? Welcome to some more online learning. We're talking about Unit 4, Lesson 1, solving systems of equations. It's going to be a blast. Take a minute right now. I'm not going to edit out that cough. You just got to, this is real life now. You got to live with what I do. I can't help but notice that most of you guys haven't even subscribed to my YouTube channel. I'm trying to become famous here, trying to become YouTube famous, maybe Insta famous, and none of you have subscribed pretty much. There's only a couple who I appreciate, my loyal followers. I could use some more subscriptions and likes, so get on there, subscribe. Let's make this happen. I need it. Okay, it's a big deal. All right, see ya. Let's do this. Systems of equations. What is a system of equations? We actually have done a little bit of systems of equations earlier on some word problems from previous units. A system of equations is when you have more than one equation at a time, right? So this right here is an equation, y equals 2x plus 2. This here is another equation, y equals x squared plus 3x plus 1. Individually, they are both equations. When you consider them at the same time, and we say that they're connected, now we're talking about a system of equations. What we're going to do is we're going to take multiple equations and try to solve them, which means essentially finding where both equations have the same x and the same y value. So where can I have the same x and same y? On a graph, what that means is you're looking for where these things will cross each other. Last year, we did systems of equations, and we mainly did linear systems of equations. So if you look at these three examples right here, you'll see three graphs where it's all straight lines. That's what we did last year, was mainly just straight lines. And you try to find where they crossed each other. This first question would have no solutions because those two lines never cross each other. Right? There's no point in which those two lines would both have the same x and the same y value at the same time. If you look at the far right, this is an equation that has one solution. That solution would be right here at 1, 2. Both lines share that point. They both have an x value of 1 with a y value of 2 connected at the same time. My dogs are having a dog fight over on the stairs. In the middle is kind of a unique situation. It's hard to tell, but both of those lines are on top of each other. That means that they're always crossing each other. That means they have infinite solutions. That's what we dealt with last year, for the most part. We had just two straight lines, linear equations. They always had no solution, one solution, or infinite solutions. That was kind of our only scenarios we ran into. Now we're going to start to look at what happens when we have quadratics. So the first type of equations you could have is a linear quadratic system. That means you have one straight line like this, that's linear, and one quadratic like that right there. The different scenarios that can happen with a linear quadratic system would be this first scenario, in which case there's no solutions. Right? That straight line will never cross that quadratic. When you look at the second picture there, there's technically one solution right in there. So we call that one solution. That linear line runs right beside the quadratic. It just touches it once and then it keeps going. And our third scenario that we could get with a linear quadratic is we could get two solutions like that. You see that both those lines cross in two spots. There are some other scenarios that we might run into when we look at quadratic systems. So quadratic, that means we have two different parabolas. This first scenario is an example of what happens and you get no solutions. The second picture is an example of what could happen right there with only one solution. This third picture down here is an example of how you could possibly get two solutions. And it is possible that the quadratic is the exact same quadratic twice, just in different form, in which case those lines are right on top of each other, and we call that infinite solutions. So you can see we just have more scenarios that we're going to run into now that we're in Math 20-1 compared to Math 10C, which we only had 3 scenarios. Now we have lots of different scenarios. And that's because we now have quadratic functions which we can solve and mess around with. Cool. Let's do some practice. So we're going to solve systems of equations algebraically. That means like by hand with algebra. The first type we're going to use is substitution. This is personally my favorite way to solve. We also will learn elimination tomorrow, and then we'll learn how to graph these things and find solutions as well. Realistically, you'd have to like kind of perfect one situation, and then you need to know how to do the other ones, just because sometimes the others are easier depending on the scenario. Cool. This is a perfect time now. If you just want to pause the video, go hit the like and subscribe button on my YouTube channel so that, you know, the world will know me. You'll never miss a math video, ever. You wouldn't want that. You wouldn't want to miss my high-quality math films, right? So go like and subscribe. You'll love it. Maybe. Doubtful. That's okay. Do it. Substitution. I'm going to jump right down here to this example. Example 1 is kind of completed for you. I'm just going to show you another example so that we can kind of like work through this together, and it makes more sense, I think. I'm going to write down some steps for substitution on the left-hand side over here. Okay. The first step that you want to do is you want to isolate one letter. Isolate one variable. If you want to write that in your own words, what that means is in one of your equations, get one of your letters by itself. If you look, this equation has one letter isolated. It's y equals, right? So that already completes step 1 for me. The second step is to substitute. Substitute isolated variable into other equation. Okay, so what that means is if you look, we got one of our letters by itself, right? We have y equals 4x minus 4. What that means is that this y should also equal 4x minus 4. So what we can do is we can take this and we can substitute it in to there. That is a terrible arrow. Please do not tell the art teacher. I'm essentially saying these y's are going to be the same thing. So if that y equals 4x minus 4, then this y should also equal 4x minus 4. That's our like substitution step. Notice that when I'm substituting and I'm changing that y to be 4x minus 4, then I'm using brackets like that. Awesome. You should notice that you now have an equation with only one type of variable. Look at that equation I just created. The y is now gone, and now all I have is x's. This means that I can now solve for one of my letters. Solve my first variable. To solve, the first thing I definitely want to do is I want to expand. So I want to multiply this 3 into the brackets. That allows me to tell what type of equation I'm going to have. After I expand that in, I'm going to have 12x minus 12 equals negative 5. If I look This is a linear equation because it's x to the power of 1. There's no x to the power of 2's. That means I can isolate variable x, get it by itself. First thing I'm going to do is I'm going to combine my like terms. After I expanded, so that 2x and that 12x becomes 14x. Minus 12 equals negative 5. Then I'm going to start to get x by itself. I'm going to add 12 to the other side. Remember, when I'm trying to get a letter by itself, I'm doing reverse BEDMAS, so I moved my addition and subtraction first. And then I'm going to move any divisions or multiplications. This is 14 times x, so to move that 14, I would divide by 14. And that gives me my first part of my answer, which is x equals 0.5. If you left that as a fraction, 1 over 2, beautiful. Awesome. Problem with this unit is sometimes people stop right there. They're like, oh yeah, x equals 0.5, and they're done. When we're talking about where these two lines or equations cross, and we're talking about solutions, we are looking for an x value that works for both and a y value that works for both. So what we need to do is our final step is we need to find the other variable. One of the reasons I like substitution is this last step is the easiest step. Find the second variable. All right, what we're going to do is I like to make a little chart. So I go over here and I say x equals 0.5. And what I'm going to do is I'm going to take that value and I'm going to substitute it into either one of my original equations. With substitution, you could substitute it into that first equation, and it works out really, really nicely. So I'm going to change that x to be 0.5. So I now have y equals 4. Instead of x, I'm putting 0.5 minus 4. Then all that I have to do is, you'll notice y is already by itself. I just have to put this in my calculator, calc, and it'll tell me what y equals. So 4 bracket 0.5 minus 2 is going to give me negative 2. That means my solution is at x equals 0.5, y equals negative 2. We usually write it as an ordered pair like that. You also could just explicitly write it like this and put that in a box too. And we're done. The value of x that gives the same y in both equations would be 0.5, and that y value would be negative 2. So my answer is 0.5 comma negative 2. That point is on both lines. Cool. Usually, okay, now this is my warning. The first couple times you see examples, you're like, oh man, I don't know what I'm doing. Then it gets a lot better, right? So you definitely want to practice your substitution and your algebra because there's lots of scenarios and lots of little tricks. And you'll get good at it. But you got to put in that practice time. It's going to be key with this unit. I feel like I say that every unit, don't I? Okay, here's another question. So it says, solve the following system through substitution. First thing you want to do is get one letter by itself. Both of these equations are already by themselves, right? I have y equals x squared and y equals x plus 2. So they're both already isolated. So step 1 is complete. Step 2 is to take one variable and substitute it into the other. What I'm going to do is I'm going to say, well, this y equals x to the power 2. Then I'm going to substitute that in for this y. So I now have x squared equals x plus 2. Step 1 was get one letter by itself. Done. Step 2 was substitute that variable into the other equation. I've done that. Step 3 is now to solve one of your variables. If I look, I have x's, right? So I'm going to solve for my x now. Usually I have some expansion to do. I don't. I can already look at this and I know what type of equation it is. This is a quadratic equation. So to solve this quadratic equation, I need to get it equal to 0. To get it equal to 0, you're going to minus x from both sides and minus 2 from both sides. So I now have x squared minus x minus 2 equals 0. You could solve using quad formula or box method or factoring. If we do a quick little factor here, things that multiply to be negative 2 and add to be negative 1 would be negative 2 and positive 1. So this factors to be x minus 2, x plus 1 equals 0. That means I have two values of x that work. I have x equals positive 2 and I have x equals negative 1. This means that I'm going to have two solutions. One of my solutions is going to be when x equals 2. Another one of my solutions is going to be when x equals negative 1. The last step is to then figure out the y values for when those x values are 2 and negative 1. I like to do a little chart like this. Because there's two solutions, that means I have two charts, like a little t-chart almost. And I'm going to take those values and I'm going to substitute it into an original equation. It does not matter which equation you substitute it into. So I'm just going to choose the first one. So I have y equals 2 squared. That means y equals 4. My first answer is 2, 4. When x equals 2, y will equal 4. That's one solution. My second solution comes from taking this value and substituting it into one of my original equations. Again, I'm just going to pick the first one. That means I have x equals negative 1 squared. The brackets here are important. If you don't put brackets in your calculator, it'll say the answer is negative 1. If you do put brackets in your calculator, it'll say positive 1. So make sure that you are putting brackets when you do your substitutions. This gives me an answer of negative 1, 1, or if you want to write it like this, x equals negative 1, y equals positive 1. Bam, that is substitution. Let's do another one. I think I have two more left. You have two more left? Oh, yeah, two more left. Okay. What I want you to do is I want you to be pausing and unpausing this video and go step by step. Remember, there's 4 steps. They're up here on this slide. Over here on the left side in purple. So I want you to try each one of those steps and see if you can get this question right. After you complete a step, unpause the video, see if you got that step right before moving on to the next step. Okay, step 1, isolate a variable. If you look, I actually already have that, right? This right here is isolated. This is y equals, so y is already by itself. So step 1 was already done for you. Step 2. Step 2 is to substitute an equation into the other equation. I'm going to substitute this into this y. Now, technically, you could have substituted the other equation in, and no matter what, you should have ended up with, on one side, you should have had x plus 2 squared minus 1 equals x squared minus 4x minus 5. It does not matter which one you substitute into which. Everyone at the end of step 2 should have that. Awesome. Step 3, solve one of your letters. So now we're obviously solving for x, since that's the only letter I have left in my equation. So go ahead, see if you can remember how to solve this function and get x by itself. My first step is going to be to expand. I have to expand this. Now remember, that means x plus 2 times x plus 2. So I'm going to have to expand that properly to become x squared plus 4x plus 4 minus 1 equals x squared minus 4x minus 5. I'm going to collect some like terms on the left side here. I got this plus 4 and this minus 1. So I'm going to combine those. And I have x squared plus 4x plus 3 equals x squared minus 4x minus 5. Now, this looks like a quadratic function to me. I know to solve a quadratic function, I want everything to equal 0. So I'm going to move everything from the right side to the left side. You could move left to right too. It doesn't really make a difference. I'm just going to choose to move right to left. So I'm going to subtract x squared, add 4x, and add 5 to the other side. So minusing x squared, I'm adding 4x, and I'm adding 5. So that on this right side, everything will go away. On the left-hand side, x squared minus x squared will actually cancel out. 4x plus 4x will become 8x. 3 plus 5 will become plus 8 equals 0. And all of a sudden, our quadratic equation has turned into a linear equation because the quadratic term, the x squareds, canceled out when I moved them all to the same side. Now, to solve this linear function, I'm going to move that 8 to the side by subtracting 8. That gives me positive 8x equals negative 8. And then I'm going to divide by 8. Now, it is possible that if you had moved everything to the other side, the other direction than I did, you would have had negative x minus 8 equals 0. And once you solved, you should have still got to the same point of x equals negative 1. So no matter how you did step 3, which is solve a letter, we all should have got x equals negative 1. Perfect. My fourth step. I need to solve for my other letter. I currently know x equals negative 1. I need to solve for y by taking this value and substituting it into an equation. It does not matter if you do the first equation or the second equation. It would be the exact same answer. I'm just going to choose to do the one on the top. So I have y equals bracket, changing x to be negative 1 plus 2 squared minus 1. You throw this in your calculator. You can actually put it in just like you see it as long as you use all those brackets properly. And you should get that y equals, I think you're going to get 0. Yeah, you do. This means that my one solution is at negative 1 comma 0. If you prefer to write it, you can write it as x equals negative 1, y equals 0. Right? But both are the same answer. What am I doing drawing my answer box right through that question? One answer, two different forms. Fantastic. Hopefully at this point, you're feeling a little bit more confident. You're like, okay, I kind of get what's going on. I want you to try this one. Again, try it all the way by yourself. Notice that it's B's and W's. That's fine. It just means that we probably won't write our answer as a point. We'll probably just write B equals this, W equals this, side by side. Again, try this all by yourself. So pause the video. While you're paused, maybe go to the bathroom, like and subscribe my video, whatever. And then come try this question. See what you can get. Okay. Step 1, isolate a letter. This is already done for us. I already know that W equals this. So I got one letter by itself. Perfect. Step 2, substitute that. So I'm going to substitute that into there, giving me a new equation. The new equation is B minus 2 instead of W. I now have negative 2B squared plus 10 equals negative 15. Awesome. I now have one letter, right? The only letter in this equation is B. So I'm going to try to solve for B. This question does have expansion that has to go on. Notice that this is a negative 2 that needs to come into the brackets. Be very careful that it's negative 2. So it becomes B and then plus 4b squared, which most people are usually good with, but then it's minus 20. Right? Be very careful that it's a minus 20 and not a plus 20. Equals negative 15. After expanding, I look at that, I'm like, okay, that is definitely a quadratic, right? My highest exponent is 2. So I need to make that quadratic equal to 0 to be able to solve it. So I'm going to move my 15 over. That gives me 4b squared plus b minus 5 equals 0. You have three options here. You can solve this quadratic by factoring, by a box method, or by quad formula. Any of the three will work. I'm going to factor it. When I factor, I'm looking for things that multiply to be negative 20 and add to be 1, which would be 5 and negative 4. Because there's a 4 right here, that means I have to include that in my factoring. It's going to be 4b plus 5 and 4b minus 4 equals 0. And then I'm going to have to remove that 4 from one of my things. It can come out of that one. So I have 4b plus 5. And I have b minus 1 equals 0. If I solve this, that means my two values are going to be b equals negative 5 over 4. Or if you put that in your calculator, that's negative 1.25. And I have b equals positive 1. Now, sometimes, remember, people mix this up and they got two values. They got b equals negative 5 over 4 or negative 1.25. And they have b equals 1. And they connect those two together and say, that's the answer. That is not the answer. Getting two different b values is telling you that you have two solutions. You now need to find the other value in those two solutions. So I like to make a little t-chart. I'm going to say b equals negative 5 over 4 on one side of my chart. The same thing as saying negative 1.25. And I'm going to say b equals 1. And I'm going to solve those two different solutions by taking those values and putting them into my equation. I'm going to choose to put them into this equation because the w is already by itself. So that means this first one to become w equals negative 2. Instead of b, I'm putting in brackets, negative 5 over 4 squared plus 10. So it's getting a little cramped over there on the side. You can put this in your calculator, right? Like you can literally put it in the exact way you see it as long as you do all of your brackets. You should get, oh boy, let's see if I can do that. I can't do that. That's going to be too hard. I had to go get my handy dandy calculator. I get a w equals 6.875. If you math frac that, that's 55 over 8. That means my first solution is that b equals negative 5 over 4. W will equal 55 over 8. That's one solution. So it's one scenario where the same b and the same w exist. In the second solution, I now have b equals 1. That means I have w equals negative 2. Instead of b, I'm putting in brackets 1. I think I said negative 1, but I meant positive 1. Plus 10. Put that in your calculator. I'm a little more confident with that one. Should be 8. That means I have an answer of w. Whoa. What am I doing? Okay, yeah, no, I'm good. B equals 1, W equals 8. And those are my two answers. That's two different solutions. That means this systems of equations would have two different points in which they cross each other if you were to graph them. Means that they have two different b values that give you two different w values, but it works for both equations. Cool. You have now learned substitution with quadratics and linears, quadratics, linears. Tomorrow, what we're going to do is we're going to do the same thing. We're going to solve more systems, but we're going to use a new method. It's called elimination. And then we'll be into graphing and some word problems. Fun stuff. Take care. Hope to see you soon. I am keeping track of who's liking and subscribing. Maybe your grades will reflect that. We'll see. Okay, bye.